So number 6 from section 10.2 is now asking us to create that simulated null distribution so that we can get a p-value and draw some conclusions. So let's go to the applet, and again, if you haven't already done it, you're going to need to paste the data in there. So you should see underneath use data that n equals 34, right? The data should be the finger and height data. And notice the explanatory variable here is finger length. That's what's on the horizontal axis. The response variable is the height. That's what's on the vertical axis. And so we think that somebody's height may depend on the length of their finger, or knowing the length of their index finger on their dominant hand might help explain their height. Now you might be saying to yourself, couldn't it go the other way around? Couldn't the finger length be depend on the height? Yeah, that could be actually. This is a case where I think the explanatory and response could go either way, but we're considering the finger length, the explanatory, and the height, the response. Okay, so what we're going to do is click on the Show Shuffle Options. And I'm going to change to data temporarily. I'm just going to do one shuffle, and I'm going to choose correlation coefficient from the group of statistics up at the top of the graph that doesn't have anything in it yet. And note to self, if you forget to do that, once you do a shuffle, you'll get an error message that will come up and say you didn't pick anything, I'm going to go with slope, and then you can just change it to correlation coefficient. So I'm going to shuffle the y values. So again, what happened is I can imagine taking all the heights and on green index cards and having them laid out and shuffling up the finger lengths and repairing them to the heights. And if we click on plot, it'll show us what that scatter plot looked like. Now, the correlation that came with this is at the bottom of the screen on the left in blue. Shuffled R equals negative 0.145. So when I shuffled up and repaired the data and put the scatter plot up there and calculated the correlation, it was a negative 0.145. I'm going to now shuffle the y values again. And now I have a new scatter plot, and the correlation that goes with that scatter plot is negative 0.01. So that's a case where the data points don't really seem to be forming much of a straight line at all, and it's even hard to tell the direction. I think the main reason is because the point in the lower left corner of the picture on the left there. Okay, I'm going to do another shuffle, and I get a new scatter plot, and this R value also is close to 0, negative 0.046. So far they've all been negative, but that doesn't mean anything in particular. They could just as easily come out positive, and again, keep in mind, this shuffling and simulating that we're doing is assuming that there is no association between the variables, that the heights are randomly paired with the finger lengths, and there is no association at all. So taller people do not tend to have longer index fingers, shorter people do not tend to have shorter index fingers, that they are just totally at random between what height goes with what finger length. So of course I want to look at this for many more repetitions. So I'm going to change my number of shuffles. I have 3 so far. I'm going to do another 997 to have a total of 1,000 shuffles and deals. And look at what we have. This bell-shaped, symmetric, mound-shaped null distribution. And notice the underneath the horizontal axis, I can't think of the label, sorry, is shuffled correlation. So when we shuffle these data ordered pairs, randomly shuffle them around and repair them, again, assuming there's no association, we expect most of the correlations to be close to 0. And by the way, if you were to click within these gray bars, just as in other applets, you can see the different shuffles and deals that resulted from that. Okay, so now I'm going to go back to the handout, and so again, notice shuffled correlation. So each point in the dot plot, and you can just imagine all the dots that are underneath the gray bars, each point in the dot plot came from a shuffle, random repairing of finger lengths and heights, and calculating the correlation. So every value in this dot plot is a correlation that came from shuffling, repairing, assuming no association between height and finger length.